In this video, I plan to derive for you the half-angle formula for sine. Now, to do that, I have to teach you something else in between, and those are the power-reducing identities. So I've drawn a little schematic at the bottom left of the screen showing you what's going to happen in this video. I'm going to start with three stepping stones, the first of which are the double angle identities. And those you should already have some familiarity with because we've already discussed those. From there, we're going to go to the next stepping stone, which are the power-reducing identities. And finally, from those, we're going to move to our ultimate goal, which are the half-angle identities. We're only going to be looking at the power-reducing identities just for a minute, but we need them in order to get to our ultimate goal of the half-angle identities. So I'm going to do the derivation of the sine half-angle identity only. Then for the next time that we meet, I'd like you to practice the cosine derivation of the half angle and see if you can do that by yourself. It really plays out very similarly to the sine derivation. And then when we meet again, we'll do the tangent half angle derivation together. Okay, so I'm going to say goodbye to the stepping stones and we'll go from there. So to start this derivation, we're going to take a look at a familiar double angle identity for cosine, and that is cosine of 2u equals 1 minus 2 sine squared u. And my objective with this is to isolate sine squared u. To do that, I'm going to move the 2 sine squared u to the left-hand side. And then I'm going to move the cosine 2u to the right-hand side. The next thing that I'm going to need to do to get sine squared u by itself would be to get rid of the 2. So I'm going to divide both sides by 2. Cleaning this up, it says that the sine squared u is equal to 1 minus cosine 2u all over 2. And what we have right there is actually the sine power-reducing identity. And you'll notice it up here at the top in the box in gray on the left. So that's the power-reducing identity. We don't need to memorize that. We're really not going to do any problems with that, but we need it just temporarily to go on to our ultimate goal, which is the half-angle identity. So leaving off with what we just did, we're going to come up to stage 2, which is to take what we just started with and make it change from sine squared u to just sine u. And of course, to do that, we're going to need to take the square root, not forgetting to do something very, very important, which is including the plus or minus. Now that we've written sine of u is equal to plus or minus the square root of 1 minus cosine 2u over 2, I'm going to go to this intermediate substitution step, which I'm going to point at in green so you know where I'm looking. We're going to let 2u equal a. Now the 2u shows up in our problem and we're going to replace that with a. Now if I take that little equation 2u equals a and I divide both sides by 2, then I get a new little equation which says u equals a over 2. And we're going to use that where it says u in the very beginning of the problem. So we're going to do two substitutions, one for 2u, which happens at the end, and one for u, which happens in the beginning. So this is going to become sine of u, or sine of a over 2, equals plus or minus the square root of 1 minus cosine 2u. But instead of 2u, we're going to put a, and then all of that's over 2. And this is the sine half-angle identity. And you'll note, if you look at the box above, it's the same thing that's written there. And the next time we meet, after we do the tangent half-angle derivation, then I'll show you some problems that we can solve using these identities. So I hope that made sense to you. I want you to try to do the same exact thing for the cosine half-angle identity, and then together when we meet, we'll do the same thing for the tangent half-angle identity.